Once we have set up the problem with our slack variables and labeling our basic variables with arrows above the slack variables, so that means that x3 at this point has a value of 2, x4 is a value of 8. x1 and x2 are assumed to be 0 initially. The first thing we need to do in this manipulation is to figure out how we can lower f the fastest. And the way to do that is to look at your function row and find the greatest negative number. In this case, that would be -4. Put a square box around that. So that is the number that you're trying to reduce to 0. And the next thing we need to do is we need to figure out which row to pivot on. In order to do that, we need to figure out a ratio of b over a. B being the value in the last column, and A being the value in the column you're looking at to pivot, so this is the one with a red box in it, the first column. As you can see, if you take B over A for row 1, you get 2, and B over A for row 2 is equal to 8. For this, you have to take the smallest one, because as you're pivoting, if you take the largest number, you could pivot into the infeasible space. So you always want to pivot to the nearest point, the smallest B over A ratio. So for F, you're reducing the largest negative number, and for the pivot point, you are taking the smallest B over A ratio. In this case, x1 in G1. So that's 1 and has a blue circle around it. What we want to do now is keep the 1 in the first position and make everything underneath it in the first column 0. That is what's happening in the second matrix. So to get the second row to 0, what you need to do is take row 2, G2, and subtract G1 from it. We do not need to manipulate G1, by the way, because it is already a 1. When we take G2 minus G1, or G1 prime, you'll get 0 in the first position. The 3 you get because you have 2 minus a -1. That ends up being 3. The next position is in the third column, so that's 0 minus 1. That becomes a -1. The last one is 1 because it's 1 minus 0. And then 8 also has 2 subtracted from it in your B column, so you end up with 6. You also need to make the -4 0, so in order to do that, you add 4 times G1 to it. You do the math across, and you get 0 in the first one, because it's -4 plus 4. The -5 comes from the fact that you have -1 minus 4 times 1, so that's -5. Then you have 0 plus 4 times 1. Then you have 0 plus 0. And for F, you're taking -50 and adding 4 times 2, which is 8. So that's how you end up with -42. At this point, there's still a negative in F. So put a square box around it. That's the most negative number. It's actually the only one. And now we need to figure out what to pivot. If you try to pivot over the first row, what's going to happen is your B over A ratio is -2, and that's a no-go. This will make B a negative number when you try to bring it into the bases, so you're done. The second row is the one you pivot over, and 6 over 3 is 2. Now, one of the things I forgot to mention is that we've now brought x1 into the bases. It's a 1 and 2 zeros. We still have x4 in the bases. x1 is now a value of 2, and x4 has a value of 6. Going back to pivoting, the first thing we need to do in the next matrix is we need to make that 3 that's in the blue circle 1. And then the first and last row need to have zeros in that same column. So we're bringing x2 into the bases. Taking G2 prime, there's a 2 missing in my notes, and dividing it by 3 will give you 1. If you take 0 divided by 3, it's still 0 in the first column. Going across in the second row, -1 divided by 3 gives you -1/3, and then you have 1/3, and then you have 6 divided by 3, which is 2. If we take this G2 double prime, we can add that to G1 prime so that you end up with a 0. So again, doing the same thing across, you're adding 0 to 1, so that first one remains the same. Then we have 1 minus a third, so that ends up being 2/3. And then we have 0 plus a third, so that ends up being 1/3. And then for B, what we have is 2 plus 6/3, so that's another 2. That's how B ends up being 4. For the function row, we now have 0, 0, because the minus 5 when we do f prime plus 5g2 double prime will go to 0. Doing the math across, you'll get 7/3 and 5/3, and then for f, it's minus 42 plus 5 times 2, which is 10. So that's how you end up with minus 32. Please note there are no negatives left in f, therefore you cannot reduce the function more. In fact, if you keep iterating on f, you will go back uphill and increase your function. Looking at this, we have a final value. x1 and x2 are in the bases. x3 and x4 are not. That means we have 0 value for our slack variables, which means that we are on our constraints. x1 is equal to 4 and x2 is equal to 2, and you get that by looking at which row is x1, 1. That's in the first row, so therefore the b value is 4. For x2, it is 1 in the second row, and the b value is 2. So at our optimal, our function value is 32, our x1 is 4, and our x2 is 2. There are some variations I want you to be aware of. The first thing is that if you have an inequality constraint that's a greater than or equal to, you end up subtracting a slack variable, and that's bad. Because when you subtract a slack variable, you end up with a -1 and a 0, 0 in that column. And so when you solve for x3, you'll get it to be equal to -2. Again, that's a no-go. B must always be positive. So in order to avoid that, we need to add an artificial variable. So we're going to add an x5 to our first constraint. Note that I have labeled all of my slack variables first, x3 and x4, and then my x5 is an artificial variable. That means I can keep x1 and x2 as my design variables, x3 and x4 together as my slack variables, and then x5 is by itself all the way over. And that's going to be equal to b. In order to do that, our artificial variable has to be driven to 0. So we're going to create a w row that is equal to x5, our artificial variable. For every artificial variable you add, you will need to add another w. And all those w's must go to 0 first, before you do any other manipulation on f. You have to get rid of your artificial variables before you do anything to f. Now, when you put this in the matrix, it still looks wrong, because we still have a -1 in the x3 position. So that's still going to give us b equals -2. What we need to do is we need to now bring it into canonical form. Because we have a -1 here, and if you look under artificial variable, we have 1 and a 0, we need to bring x5 into the bases. And we do that through a single row manipulation. So this is only because we're bringing it into canonical form. We're going to take G1 and subtract it from W. When you do that, your W row becomes -1, because that's minus G1, 1, 1, 0, and 0. So look, you have now brought x4 and x5 into the bases, and W also needs to have 2 subtracted from it, because that's, again, the value of B in G1. This means we now have a negative in W, and we have a non-zero value of W. So the first thing we're going to iterate is on W to make it disappear. This is not actually true, and this was an infeasible solution because obviously I just messed around with the greater than or equal than sign. Our next example will show what to do with an artificial variable.